Elastic Security empowers security teams everywhere to prevent, detect, and respond to threats quickly through a unified solution. And it's free and open, putting you in control. Use Elastic Security to eliminate blind spots by analyzing all of your data, no matter its volume, format, or age. Stop threats at scale with automated threat and anomaly detection, and arm every analyst with fast search and integrated case management. Download or try Elastic SIEM for free and experience the benefits of an open security solution backed by world-class security research at securityweekly.com/elastic. The question is simple. Have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM. Welcome back, everyone, to Paul's Security Weekly. This segment is being recorded. I'm in the bunker, so I mean, get used to that backdrop. It might change, but for now, I'm in the bunker. And would like to make an announcement. Our next webcast on September 10th will teach you how to extend the enterprise network for remote workers and protect your home network. Learn how to plug security holes required to meet a zero-trust security model on September 17th. securityweekly.com/webcast to register for our upcoming webcast, and securityweekly.com/on-demand for the previously recorded ones. Mr. Tyler Robinson and Lee Neely are on the lines remotely. Welcome, gentlemen.
Thank you.
Good to be here.
Nice to have you. So, I'd like to introduce our guest to talk about very much about vulnerability prioritization, which is still a sore spot, I believe, in our industry today and with many security professionals. Here to do that is Roy Cohen, currently the co-founder and VP of Sales for Vicarious and a cybersecurity expert with over 15 years of experience, former research team leader at CyberArk, penetration tester, and graduate of Elite Technology Unit at IDF. Roy, welcome.
Yeah, thanks, and great to be here.
Shani Reiner is here with us as well. She has 10 years of experience working as a cybersecurity researcher and data scientist. Her malware research has led to the development of the industry's most advanced analysis tools. Shani holds a BSc in computer science and an MBA specializing in finance strategy, entrepreneurship, both from the Hebrew University of Jerusalem. Shani, welcome to the show.
Hey, Paul. Very excited to be here.
Yes, this is. I'm excited about this segment because I really believe I'm excited to be working with Vicarious because vulnerability prioritization, patching, all of that stuff is very near and dear to my heart. And I think it's time for a lot of different shakeups in this particular arena. Roy, I want to just kind of go over to you and Shani and talk about kind of your approach in general to vulnerability identification and prioritization.
Great. Thanks, Paul. So actually, we thought about today to discuss a bit about how to predict vulnerabilities and also first, what's the importance and motivation for doing so. As we know, vulnerability, let's call it management, is manually relies on past exploitation, past vulnerabilities. It means that there is a vulnerability which was disclosed somewhere in some point in the past. And upon such disclosure, a company gets in some way some notification, and then it needs to take an action. But if you recall, historically speaking, I think the CV concept was kind of introduced in 1999. If I'm not mistaken. By that year, there were like only 1,000 vulnerabilities published that year. Getting to today, there are over 1,000 vulnerabilities disclosed every month. So I think there's like quite a straightforward motivation to why to try to find vulnerabilities beforehand, like before hackers do.
I'm sorry, Roy. I got that introduction like not completely wrong, but pretty wrong. I apologize. We are going to talk about predicting. Which is an aspect of is basically prioritizing what you didn't previously know about that hasn't been disclosed, correct?
Yeah, definitely. So imagine, again, we are pretty confined to the concept of a software is vulnerable only upon a public disclosure, and up until that point, it's considered to be safe. But it doesn't really matter. Every vulnerability that is disclosed these days, probably the application was used before. So unless there is a public disclosure, we still believe applications are considered to be safe. And because of the increase of threats and vulnerabilities, and also automated techniques to find vulnerabilities, we think and we feel what we try also to do somewhat of an education is to help companies to know beforehand if they are using a vulnerable application based on binary analysis, based on examining the compiled code and see if there is like inner threat which may in turn be used against them. So I think that the vulnerability management today, which is kind of confined to things which are prior knowledge, should be shaken a bit, and companies should be aware if there is at least something which in turns may be compromising their network.
So Roy, I mean, basically you've taken a security researcher with IDA Pro and turned them into an AI bot. I mean, that's kind of a very sensational way of saying what you were saying.
Precisely. Imagine having a reverser sitting 24/7 trying to find stuff across applications you are using, even proprietary. Probably the vast majority of scanners will be, again, confined to applications which are probably well-known off the shelf for operating systems, not necessarily to applications which are customized or proprietary software. And let alone applications which are obsolete. Eventually a vendor at some point in time says, this application is no longer maintained, and a lot of customers all over the world are still using the application. So now what question is being asked? How do I know there's something here which in turn can be used against me? So trying to look, into the future, not be confined to to CVE concept or known vulnerabilities. This is like the big story we're trying to tell here.
Roy, what kinds of things are you looking for in the binary analysis to determine that there's a vulnerability?
So before we skip to that, actually, we heard some exciting stuff for you. So we would like to do some, to go through an exploit together based on the time limit that we have during the session, but we'll do some analysis together. We're going to analyze to some extent how it's being done manually. Then we would like to discuss how we can scale that, and in the end of the session, we're going to show like what vicarious are doing, if that's okay.
Yeah. I want to turn over to Tyler and Lee as well, and have them ask some questions, because I'm sure there's some questions burning on your mind now.
Yeah, this is pretty interesting from an exploit like predictability standpoint. Like there are known malicious kind of key indicators that a lot of exploits or vulnerabilities end up leveraging, but the ones that are typically like living off the land or abusing certain functions, does this have the ability to kind of identify the misuse of common tactics as well, or is this simply looking for exploit paths within inside of an application, an OS, a piece of software?
Well, when you look on the spectrum over how a vulnerability can be found on binary, you have multiple ways, and we're going to describe them. So some of them are like what you've mentioned, to the ability to identify like pieces of code or like snippets which are known to be exploitable or potentially can be exploited under some certain circumstances. So yeah, these are speaking about vicarious. So yeah, these are kind of the things we are also looking for.
Does it also identify like libraries and stuff that are being leveraged with inside of the binaries, or functions being called from inside the binary?
Precisely. So what we are specializing is that we actually analyze the binaries level vulnerabilities rather than, I know there are plenty tools to do it on the web application level. We are kind of specializing on the binary level.
That's pretty cool.
So are you just analyzing the static binary, or are you doing something in a detonation chamber, or a little both?
Yeah, so it's actually a good point, Lee, because obviously statically analyzing the binary can get you to some point. Obviously, we have obfuscations and behavioral, environmental kind of variables which should be met. Today, we are focusing on static analysis, but we're always extending the portfolio of things that we support.
Yeah. And I know it's non-trivial, so you got to start somewhere.
Yeah, tell me about it. Yeah, we want to find everything, but you need to start at some point, and extend from there.
Well, please identify all the unknown bugs before we go to production, okay?
Will do.
And it's interesting too. The binary analysis, it doesn't matter what operating system or processor architecture, right? If you're looking for the exploitable functions, that can be independent of any kind of architecture or what operating system it was built for, right?
Yeah, precisely. And imagine every vendor is acting to some extent like an island. So they are getting like, let's say there's a responsible disclosure. They're getting like an insight. There is a vulnerability in one of their applications, and they're fixing it. Okay, they take an action, they fix the vulnerability, but the technique can be used for other vendors, maybe other vendors also in the same space of applications. Imagine a database application. So some vulnerabilities that we also identified, we saw the vulnerable snippets of code can be used on other database engines. So
wow,
imagine,
now, Roy, you're being too kind. Typically, when they fix one bug in one piece of their own software, right, that exploit path is in 2 or 3 other places, and oftentimes they miss that, which I find amazing. Microsoft has even missed that. Right?
Yeah, I don't want to mention any vendors, but yeah, that's precise. There is a common phenomenon where there is like a release cycle of patches to reverse it, to see what was changed, and then to search for these kind of bugs in other locations in the code. So you're spot on there.
Right.
That's how most of the bypasses work, right?
Yeah, right, exactly. But it's interesting that your software, Roy, and Shani can detect this, right? And even and we'll talk about I hate the term virtual patching, right? But put a remediation out for it, because that's, I think, a really interesting scenario. Yes, there's a major bug that's been released and there's been a patch, but now the eyes of all of the evil people who are writing exploits are on this code, and they're going to find instances of it, and you're going to be a target pretty quickly. So having your technology, I think, puts you in a really good shape for particularly this scenario, as well as lots of other ones too. But it's kind of interesting to think about it in this context.
Likewise. And if we are to get our hands, though, it would be great to show like how vulnerability is detected. First, we would like to show an exploitation, and then how vulnerability is going to get detected, and of course, then we can discuss about how to scale that. Of course.
Yeah. No, I think that's great, because I think when I was first hearing of this, I'm like, oh yeah, like I used a really ghetto way of just running strings against the binary, and if I see stir copy, you got a buffer overflow, right? I'm sure it's a lot more complex than that, right?
Yeah, definitely. There is a lot of things to place there, because again, let's say open source tools or things which are kind of result of short-term projects can get you to some point, but it does require to be a bit more precise eventually, unless you want to bombard your client with tons of alerts. You need to focus. You need to do to some extent validation. So yeah, there is a lot more into that than just showing a known to be malicious string or a sensitive function.
Right. Okay, well, if you want to shift to the demo, I think is a good time to do that.
Yeah, so Shani, I think the floor is yours.
Thanks, Roy. So as Roy mentioned, every month there's over 1,000 vulnerabilities are discovered, and one of them lately was discovered by Stefan Schiller, and he discovered a format string vulnerability in an AnyDesk 552. This vulnerability can be used to gain remote code execution by sending a single UDP packet to the target machine. So let me share my screen with you, and we can test this exploit for ourselves. Okay, so first we will set up the attacked host. So the host is Ubuntu 18.04. I already downloaded the AnyDesk 552, and now we'll log in order to the desktop in order to open the app. Sorry for that. As you see, we use a long, complicated password.
That was password 123 twice, wasn't it?
Actually, no. Even for demo, we use very complicated passwords. So here we open the AnyDesk app. Let's check the process that it's all running. ps-aux ref AnyDesk. Okay. Good looking. Now we will check the open ports. Next step. -tu-nlp. We'll grep again the AnyDesk. Okay, and as we can see, there's a UDP port open 50001, and this is great because this is the port we will be using for the attack. So now we'll be using the framework of the Metasploit. So let's open that in the subconsole.
Yeah, it's also refreshing to know that single packet UDP exploits still exist. Well, there was a TCP/IP framework that had it in it, Ripple 20, and we covered it last week. So it's good. Great examples. Love it.
So here we'll be using the CVE 2020 13160 of AnyDesk. And let's use the show options command to see which options we should set. So as we see, we're missing a host, and the target is not the target we are using because it's Ubuntu 24 instead of 1804. Let's set that up. So set our hosts 10, 0, 327. And let's look at the list of targets. So sure. Okay, so the ID we need is 1. Let's set that. Okay, just let's have a quick look to see that all the options are correct now. Okay, looking perfect. Let's try an exploit. Okay, so now we can open a shell and execute a command such as hostname. Okay, so now we received the attacked hostname, Ubuntu 1804 exploit, and this is great. If we were an attacker now, we could have used a malicious command instead. And so let's talk about this attack. What happened here? So what is exactly this format string and why is it risky? So a format string exploit occurs when the submitted data of an input string is evaluated as a command by the application. In this way, the attacker could execute code, read the stack, or cause a segmentation fault in the running application. The attack could be executed when the application doesn't properly validate the submitted input. For example, if a format string parameter like %x is inserted, it will be converted into a format, and the arguments that are not supplied would be instead read or write from the stack. So in order to see exactly what this vulnerable function is doing, we implemented a simple code that can demonstrate it, and we can debug it together. Okay, so let's look at that code. We called it attack. And if you can see on my screen, what this code does, it asks for the secret key and prints out if it's true or not, and prints also the secret key. So, the secret key that was entered. So let's try it out. So at first, I put a false secret, my secret, for example. And if you can see on screen, so my secret isn't the secret. And now we will try the valid code. So level 1, and you're right. So now for the demonstration, I would like to enter %p. This is a formatting of a pointer. Sorry. We'll do that many times in order to receive what we want from the stack. Okay, and we received here all kind of hexadecimal numbers that we can convert into ASCII. I'm sorry, this is wrong. And we received our password out of the stack. So actually what this demonstration shows us is that using this vulnerability, we can receive data from the stack or even write to the stack like they did in AnyDesk vulnerability. And now we would like to debug this program, but because of the time limit, it would be hard for us just to start from without any hint. So we will use kind of an open source that here will shorten the path and for us helps us to scale. It's a WE checker that we will run on this code, on the attack code, and we will wish that we would give us a hint for where to start debug. So meanwhile, CWE checker is an open source for discovering common bug classes. And in this case, it found our function, the snprintf, the dangerous function that is vulnerable. And Roy, can you please now debug this function?
Yeah, sure. So as Shani presented, essentially there was the vulnerability in AnyDesk where, again, the UDP packet which was sent was triggering, eventually it got to a vulnerable risky function. And by facilitating the format string feature, so to speak, it was allowing the adversary to write on some locations on the memory space of AnyDesk, shellcode, and eventually let us to do some, accomplish a malicious activity. So what we want to show here...
I'm sure the AnyDesk developers like to think of it as a feature and not a bug.
Definitely, don't we all? So let me just connect to this computer and let's do somewhat of a debugging. So I will be sharing, of course, my screen here.
It's AnyDesk admin mode.
Yeah. Yeah, anywhere, admin, whoever. So let's see here how it goes. I know there's some, I need to connect here again. Okay, so let's put it aside for a moment. Okay, just log in. Cool. That's no longer needed. So what we're going to do next again is we are going to simulate the attack. Okay, so let's run that. Okay, the attack is running. Now it's waiting for user input, so there are no issues here we can attach to the process. So again, let's do that. Open the, here we'll be using EDB debugger. Okay, and we need to run with the elevated user because we are debugging the root process. So let's do that and attach the process. Okay, so let's do that. So we are now attached. Let's continue the execution. So as Shani showed us using the CWE checker, we found that there is a potentially use of a dangerous function, snprintf. So what we're going to do is basically place a toggle a breakpoint there and to see how it goes once we get to that risky function. So let's go to the simple viewer, type in snprintf. We see it's being used in our code, so let's double click that and then toggle a breakpoint. Here we go, and we are running. Great. So let's get back to this small simulation. and type in 8 times this parameter. Again, it's a reference for a pointer. I hope you're counting because I'm not. 1, 2, 3, 4. Okay, I think we should be. Let's have one additional just for a case. And in case, okay, so we typed in the input which will trigger that vulnerability, and we hit the breakpoint. As you can see in the register, we have the input which was placed. Mm-hmm. And then by moving forward, I will skip this execution. Okay, no need to go to dwell into that. Okay, so by examining, let's see, I'm not in a breakpoint. By examining the stack, I can show that we have, okay, we have that string enumerated, as you can see in the stack. This is also equivalent for what Shani showed us before. Okay, it's the same string, essentially. Now, just wanted to show that the content is basically parameters from the stack because we didn't provide any external parameters for it to build the string from. So what it does, it just goes to the stack and just pulls one by one. And on the 8th attempt, it actually reaches the 31 hex code, which is the number 1 of our password. So just looking on the last 4, you can see we got the one which ends with 31, 0x1, 100, and 728. If we're going down the stack, you can see that of our password, which is stored here, is actually the last parameter, which was printed before we got the 01, the 100, and 728. So as we can see, the format string builder was actually taking the input from the stack and giving us an option to get a hold of the password off the memory. Now, obviously, doing that one by one for every application and trying to accomplish this, it's not scalable. And doing a manual process, I remember days I was spending for identifying vulnerabilities. It's quite tough. So I'll let Shani to describe a bit how this kind of process could be done on a scalable manner. Unless you have any questions, I'll be happy to take in regards.
Right. EDB, the debugger provided the command line and the graphical interface?
Yeah, it's both.
Okay.
The command line, it's not a command line debugger, it's a visual debugger.
Yeah, I got you. But you started, I see, from the command line and it spawned the graphical debugger?
Yeah, exactly. Okay. I spawned it, and because there is an fget function, so basically it waits for a user, so there's no issue here to attach. Usually, if you have like quick processes which just get loaded enough, it could be tricky there. But here there is it's waiting for a user input, so there's no we can take our time and attach. Yeah.
Yep. Awesome.
Yeah. Sure. So I'll hand over the mic to Shani to discuss a bit about scannable ways to find vulnerabilities.
Thanks, Roy. So as we saw, discovering vulnerabilities using a debugger is time-consuming, even when we use the small example. And most softwares are much complicated than this simple example we implemented. And as an attacker, it might be enough to find one or few exploits, but from the protection point of view, we need to find all the vulnerability, or at least to try to find all the vulnerabilities that exist, and to find them before the attacker does. So due to the increase in the vulnerabilities and of the attacks, so we need to find a much scalable way to do this process. And there are some kind of different tools that are developed in the market. Some of them are even open source. We would be happy to mention a bit. So for static binary analysis that models the assembly code and produces graphs such as control flow, data flow, control dependency graphs, we can use ANGR, Radar 2. There are different techniques such as Feathers. This is an automating software testing technique, automatically providing invalid, unexpected, or random data as an input to computer programs and check its behavior. Such we can find as AFL, OSS fuzzing. And of course, there's the third technique of looking for CWE detection, such as the one that we detected. These are common bug classes that could be found in softwares. And we can get hints or even maybe find vulnerabilities using these techniques. So, Paul, these tools are now maybe help us to scale the process, but this is not enough if we're looking about the future and the upcoming days. So we think that we'll be having much more vulnerabilities, and we are looking for even innovative techniques for that. And we can see that all kind of researchers all around the world are looking into how to apply machine learning techniques in these tools in order for us, to go to the future and still could be able to detect them before the attackers does.
Yeah, and Shani, I think the tools that you mentioned are helping automate tasks in the vulnerability discovery process for a researcher, right? And where you and team have taken it is really to that machine learning and automating many of those, the discovery of many of those techniques, right? And that's where I kind of see that shift.
Right, exactly. So we see just like state-of-the-art researchers that were published lately. We can see all kind of researchers through CWE detection methods, while the limitation with the current tools, as you said, is that they're based on existing patterns, they are created by experts, they require time, effort, cost, how to keep them up to date with every vulnerability that is discovered. And researchers are now proposing a new method of using machine learning to model assembly code and using the algorithm that is based on word2vec, and they learn the features of the software weakness code using these feature extraction of text CNN without creating patterns or rules. So this will allow us to detect new software weaknesses. Other researchers show that they can predict dangerous memory corruption. They use, they extract static features by looking into the sequences of calls to the standard C library functions in the program, and they treat them. They treat each call trace as a text document. Then they can vectorize the data using the text mining techniques such as n-grams and word2vec and predict programs that contain dangerous memory corruption. So yeah, there's a lot of challenges with these new techniques. There are still, most of the tools today support source code and not binary code. And as we know, vendors might use these techniques before they publish the software, but we, in our state of mind, we look onto binary code. Also, most of the binaries might be too large to be useful in like the practical inspection. We could have computational challenges, and also sometimes the environment where the binary is running is different than looking in a static method. So yeah, we're always looking into new and innovative techniques in order to help us, overcome these challenges and be able to predict all these vulnerabilities in advance.
So the prediction and patchless protection, right, which I did want to touch on a little bit, because not only do you identify these vulnerabilities, but you're able to patch is the wrong word, I think, is what we agreed upon, right? It's not really a patch, really just in-memory protection for this specific vulnerability, rather than a very generic memory protection, which is, prone to false positive and false negatives. You can provide a very specific memory protection. But getting back to the discovery of the vulnerabilities, these don't have to be zero-day vulnerabilities, right? These can be a vulnerability that's been released, and you can still use the same method, especially since the patch is released, to identify that vulnerability. Is that correct?
Yeah, that actually makes life easier. If you have public disclosure, and even better, if you have an exploit and a patch, this is kind of what allows you to be, first, let's imagine you predicted a vulnerability. Then it allows you to know if you were right, if you are hitting on the spot. And then in turns, if your protection was effective as for example, as for the patch. So yeah, this is actually something which is helping, of course.
That's awesome. Tyler, Lead, more questions?
So I was thinking that you've got some ideas. I'm thinking, but you've got an extreme scaling challenge. How are you looking to really scale to get all that detection and identification done in a rapid fashion, or is that one of your hard problems you're still trying to solve?
So it's a good point here. Yeah, so in terms of scaling, I think this is kind of the main drivers for us to start off binary analysis rather than trying to emulate stuff in memory. So it's good to some extent, allow you to find some issues like we saw just here, giving you some hints about potential issues. So binary analysis, the way we do it today is quite efficient. It's a few, up to a minute. It's a matter of seconds to minutes for us to identify a given binary based on the techniques that we support, of course. But it's a good point that once we would like to extend the reach for things which are a bit more dynamic, like let's say supervised fuzzing or some more deep, eventually when you do also binary analysis, there is some limitation on the recursion level. How deep are you getting? So yes, we saw these limitations and we are unveiling always new ways to overcome these. But it's a good question, and obviously it's a limitation for why not to apply all the techniques at once on every application. It's something that definitely requires significant computational resources.
Well, I was actually also wondering if you found something, say at Paul's company, would you then shortcut the process at my company to discover if we have the same issue to worry about?
So because it's a binary analysis, eventually the same, and the techniques that we do today are not based on environmental changes. If we found a given binary, we found a vulnerability on company A, and it's the same hash for company B, then assuming they have the file, we found the hash there, so we can just we can spare the analysis there. We can just show, okay, these are the results for that hash. Obviously, once we're going to introduce dynamic features, it will be different. Some of the assessments will be needed to be done again and again for every client. But for the binary analysis, that's correct. It's not needed to duplicate the same results.
Nice. Yeah, because it seemed like... Go ahead.
No, go ahead.
I was kind
of curious around the idea of where you're doing the static binary analysis. Is there the potential to do dynamic binary analysis in memory as the binary is being loaded, or as the operating system is getting ready to execute it and kind of analyze that as it's being utilized, similar to what you did with the breakpoint, right? Is there future plans where you can look at the binary in memory as it's running and identify potentially dangerous functions being called with that binary?
Yeah, so it's a great point, Taylor. I think without stealing the thunder of the Patchless protection session, I can say that we are using for the in-memory protection, we use the dynamic binary instrumentation, which traditionally was used for debugging. And we kind of heavily tweaked that to be adjusted for security without the significant impact on performance, because as you know, when you debug a process, then it's quite chaotic in what goes there. So we are facilitating dynamic binary instrumentation techniques to do the protection. But of course, in turns, it could be used for doing the dynamic analysis. So that's a good point, and this is definitely a space we are deeply looking into. Look, there are so many techniques for us to try to find vulnerabilities from. It's a matter of priorities. Once we get to the dynamic, there is, of course, a question of which machine you would like to evaluate, because some vulnerabilities could be represented on the server rather than on a desktop, on machine A rather than machine B. So it's also a question not if you can accomplish it, but also where and when. But it's a good point.
Yeah, definitely.
What's the impact of the analysis on the end node, whether it's a workstation or a server? How much is the overhead for doing this? I mean, it seems like it wouldn't be horrible, but you wonder.
Yeah, so all of the analysis is being done on the server side. So it means that the tenant, assuming the hash wasn't uploaded from anywhere else from our customers, globally, assuming the hash wasn't already analyzed, then the server is smart enough to pick and choose which computers need to upload based on their consumption, based on their performance. It would basically copy the binary to analysis on the server side. Then it will do the assessment over the binary and remove the file because we have the results. There's no need to do another assessment at that point. So there's no computational resources or impact required from the end node. It's more of the server side. It's mainly, copy a file to the server. That's it.
Yeah. So you guys built cloud first, right? And everything goes up into your cloud for analysis, which means the user can be anywhere. Yeah,
I think this is also something which is quite. We put a lot of effort into. Imagine having. Today with the remote workforce and people working from home, you want to have a visibility, they installing stuff from wherever, whenever. I think we have a few clients which kind of lift the levers and every user now got an admin because it's very hard to support them globally. Imagine someone taking a laptop back home and he needs a new software. Imagine pushing a new software there. Imagine seeing what's going on. So cloud first, it's something we had, very deep into our core, the ability to break the perimeter and to basically support everywhere and anywhere. Also in the sense of analyzing and predicting vulnerabilities. And I think maybe speaking of which, maybe I can show a bit how it's being represented on the dashboard, if we have a couple of minutes. Not going through a full demo, but basically, as you can see, the system gives like an overview of all the threats. It's real-time visibility, all of the threats that are shown for a given environment, and found these many vulnerabilities and potential hints and issues that are found in the code. Obviously, there will be exponentially more unknown threats than known. That makes perfect sense. And once we would like to go specifically for AnyDesk, here we can get to the operational screen. So we got AnyDesk, and examining the analysis, definitely we can go and see there is this the version which is vulnerable, format string vulnerability, which allows an RCE, remote code execution. But also examining the zero-day framework, this is the result of the binary analysis. Obviously, we're not going to be an exploit factory that people can be used that for their own malicious intents. We're like obfuscating that and giving like a general category of what could be found. So we are telling the client, look, there is an option here to exfiltrate data. We found 19 functions which are related to that. And then the now what question is being asked. Once we get to the patchless protection session, of course, we're going to discuss that. But the goal here is to show a client, look, even if there is or there isn't a known vulnerability, still there is something here which in turns can be used against you. So you can have the upper hand. You can have the prior knowledge before waiting for a public CVE to be disclosed. So this is, again, what we're trying to show here.
That's really awesome.
Yeah, thanks.
And that's prioritized, like how in the interface, right? Like the zero. Let's just say that in AnyDesk it was a 0 day, right? Like what are the other items that you're prioritizing around in AnyDesk 0 day exploit, as an example, in someone's environment?
Yeah, obviously for a 0 day exploit there is no CVSS score. Obviously there is no vector which we can rely on. I think with Michael's session he kind of discussed of how we parse the vector and try to connect the dots. Like if a vulnerability requires high privileges, we check if the process is running with the high privileges on a given machine. It's not these data points are not available on a 0 day. What is available are somewhat dynamic properties which can be facilitated. For example, imagine we have a vulnerability we found around network activity, network-related attacks. We have some categories, some of them related to that. So if the application is not actively, communicating with the network, obviously the 0 day, the vulnerability we found has less importance. Okay, there is a domain of attack we found around the world of network, but the application isn't communicating with, it's not networkly active. So obviously the weight, we are associating weights. So the weights associated with the risk of that giving 0 day is significantly lower than other things that we find.
Right, and what I like about the Vicarious platform is I don't have to tell it a whole lot, right? Like you give me a very subjective risk score, as you said, this process is communicating on the network or it's not, right? And then there's the automatic context that you're putting it in. It is talking on the network, but it's not exposed to the internet, or it is, right? And you're doing all of that calculation for me and finding vulnerabilities that are potential 0 days. And I can just go into the interface and see what's most important to me on any given day at any given time, correct?
Yeah, that's correct. I think this is what we are trying to accomplish, is to be first a unified platform from the point of disclosure, for finding the vulnerability, again, known or unknown, through the decision-making process. We know this is something which takes a lot of time from companies to try to know, okay, there are so many vulnerabilities, and try to pick and choose the one you should be focusing and putting into your plan of fixes, and eventually fixing it. So there are always gaps when you do a scan and you manually try to prioritize or to try to utilize some tools, and then try to shift the responsibility for someone else to take ownership of the process, to fix it, and then try to do the loop back. So what was important for us was to be able to show the alert, to focus on the ones who matter, but also provide the mitigation. So I think while we are quite speaking of identifying or finding vulnerable spots, we are quite, let's say we are faster there in the process of finding new techniques and facilitating them. The protection obviously takes a bit more cautious, because you cannot just do whatever you want. You need to be testing techniques. So we're trying to, when we find an issue, we work very hard to make sure we can offer a mitigation as well, not just, again, bombarding clients with alerts they have nothing they can do about. So when we introduce a new technique to find vulnerabilities, we usually release it when there is actually a protection manner which can be applied upon. This is in relation to the patches protection. So this is how we try to close the circle. You find stuff, you prioritize based on a vast majority of indicators. It could be external facing, it could be dynamic, like how the application is being used, what is the token, which ports are open, who is it communicating with. There's a lot of data points we are collecting and facilitating into that.
So 2 questions.
Go ahead, Lee.
So when you identified the risk, do I have visibility to the information behind that risk level? As you had mentioned, there were indicators you found. Can I, as a customer, see what they are? And the second question is, can I recast the risk based on my situation?
So today, in the sense of looking on the risk, there is a technique we call it X tag, which is basically exploitation tags. We are tagging the data points, which are either external or internal. So we are tagging the data points in relation to the application. Imagine you have, let's say, a Java application. Mm-hmm. So this Java can be deployed, and this is a true story. Let's say you have infrastructure like a server farm of 1,000 computers. And Java, let's say, is installed on each and every one of them. Right. And every other day there is an update. Not every other day. Let's give them some credit. But there are a lot of patches released over time. Mm-hmm. And then we had a client which actually was, initiating a new patching cycle for 1,000 seats over and over and over. And when we deploy the system, one of the interesting data points that we show is, for instance, if an application is not loaded to memory. So imagine now you have Java on 1,000 computers. You are maintaining it for years, right? You are updating and trying to fix it. Mainly the driver there was security, not features. The application is running, but they're trying to keep it up to date and secure. And when we deployed that, we saw that around 80% of the servers were not using the Java whatsoever. So the Java worker was never loaded to memory, therefore it was not used. So imagine how much, well, at least he cannot, not saying to uninstall it, of course, but at least he can just to focus on the ones who actually use the application. So this tag has a weight associated with it. And assuming it's met, we found the criteria which we are checking. It can either increase or decrease the risk. So you as a user, you can filter by any given indicator that we provide, but altogether we are providing an algorithm, like a battle-proof scoring system, which is tested throughout from SMEs to Fortune 500 companies. So today we're bringing it out of the box, but in the future, you will be able to adjust it. And imagine, Lee, that you can take a risk model that you have today. Mm-hmm. Some of the bigger companies have a risk model. Imagine you can adjust it not saying, okay, having a risk model and then there is a lot of effort needed to be synced or to change it. You can adjust it on the spot and then see how the entire risk of the company change based upon your decision. For instance, if something that has an exploit now should be super high categorized, and then you know what, not having an exploit, maybe something which is weaponized and is not communicating with the internet. So you will have the luxury to change the risk model based on your need and in real time.
So it sounds like I could really make the argument about taking action because I could show what would happen more easily if we don't, which would be good for supporting the our argument from the security team when talking to management that is not quite as hip to the consequences of the decision, pro or con. That would be huge.
Yeah, imagine, yeah, exactly. Having no need to fight with the CIO or the CEO, depends on the size of the company, why you didn't patch your 7-zip. So,
we'll still fight with them.
Well, that's what I like too. The term patchless is overloaded in the context of vicarious, right?
yeah, it's ambiguous. You can look in different ways, patchless or the patchless technology. Definitely what we had in mind.
It's awesome. For folks that want to learn more, visit securityweekly.com/vicarious. You can start your 30-day free trial today by submitting some basic information. And if you want to check it out, kick the tires on it, I highly recommend that you do. You folks are doing great work. Roy and Shani, thank you so much for appearing on Paul Security Weekly.
Thanks, Paul. Thanks, Lee. Thanks, Taylor.
Thanks, Tyler.
Paul.
And thank you. Thanks, Tyler and Lee. And thank you, everyone, for listening and watching. We'll see you next time. Over and out.